is Robert Acevedo, and I'm going to be talking about the visitor design pattern. So first here is an introduction. The visitor design pattern is used to add new operations to classes without changing them. To give a general overview, the element objects are the objects with classes that we want to add operations to, and they will have an accept method where they accept a visitor object. This visitor object will handle the implementation of the new operation tailored to all relevant element types. I'm going to go more into detail on this later on. So now, why would we want to use this design pattern? If a project has many different element types that all need a new feature added, it's going to be much easier if we add this behavior to a visitor rather than go to every element class and add the changes. Another reason is, in a real-world setting, if a feature wants to be added, it can be risky to modify a pre-existing class, so maybe using the visitor design pattern is safer because the classes in use don't need to be changed. So here's a real-world example of where the visitor design pattern could be useful. Think of an online shopping cart where you have many different items that can be added. So if we create a visitor that all the items can accept, the visitor can, for example, calculate the price for each item. And I'm going to give a code example later on. So this is the structure of the design pattern. We have the element and visitor interfaces, and then concrete elements and visitors, and then also the client. The client first interacts with the concrete visitor by creating an instance of one. This concrete visitor will have the implementation of the new feature we're adding. Then the client has an instance of an element, we'll just say for this example element A, and calls accept on element A, passing in the visitor. Then the element interface has the accept method, and the concrete elements will override this accept method. So in this case, the concrete element A, will override the accept and call visit within the visitor interface, and then pass itself as a parameter. In the visitor interface, the method that accepts element A will run using the implementation of the concrete visitor, and that will get you the desired operation. So here are the advantages of this design pattern. First, it's an open-close principle, where it enables adding new methods without changing the original classes. Again, this is great for real-world applications where changing pre-existing classes isn't safe, and also makes it easier to add new features. Another benefit is for data accumulation. So since you have a visitor, that visitor object that's going to be interacting with many different object types, data on these objects can be saved and used for other uses. So if we go back to that shopping cart example, if we're keeping track of the prices you calculate for every item, then we can keep a running total and then get the total cost for the entire shopping cart. And then finally we have single responsibility principle. This lets you create different versions of the same feature. So an example of this could be calculating area. Say we have elements of a circle, a triangle, and a square. To calculate the area for these shapes, they all have different formulas, so you can tailor the implementation to each formula for finding the area. Some disadvantages are if you were to add new object types, all visitor classes need to be updated to account for them, which kind of defeats the purpose of this design pattern. Second, visitor classes won't have access to the private variables or methods, so if that information is required, then this design pattern won't work. And finally, since we're adding a lot of classes, such as the visitor interface and the concrete visitors, this increases the complexity of the code and can make it difficult to manage. So I would use this design pattern if I want to add a new operation to many different element types. If my classes have extra methods that go beyond the core purpose of the class, it could help with organization to also put these methods into a visitor. And then lastly, if you have a class hierarchy and you want to implement a feature that only applies to certain classes in that hierarchy, a visitor would be able to do this. So now, to avoid it, or you should avoid it if you know the element classes are going to be added and removed frequently, because again, you have to make changes to all the concrete visitors, and that defeats the purpose of the design pattern. Again, if private fields or methods are needed, then the visitor won't have access. And finally, if a method is very simple to implement, it may just be easier to implement it in the classes themselves because the extra calls with the visitor could affect runtime, so if it's unnecessary, then we don't need it. So implementing this design pattern, you first start with defining the element interface, which will accept the visitor. Next, you will create concrete classes, which will implement the accept methods. And then we're going to create the visitor interface to declare a visit method for every concrete element type. And then we're going to create the concrete visitor to implement operations for every element type, tailored to those element types. And the element will call the visitor method passing itself as a parameter. So now I'm going to go through my code example, which again is using the shopping cart example. So first thing I did was create the element interface and the visitor interface. So the visitor interface has the visit methods for a book type and a fruit type declared. So those are the two items we're going to be working with. And then I created the element interface, which is item, and that has a general accept to accept the visitor. Then we have the concrete elements. The book and fruit has its own properties, you can see, and its own methods. And they both override accept, and they're passing a reference to themselves when they call visit. And finally, here is the concrete visitor, which is based on the pass-in item, and it prints out the price differently based on what item is passed in. So as you can see for book, the book has a flat price that we print out, whereas the fruit has a price that depends on the weight and price per pound. So if a fruit object were to be created, a concrete visitor will also be created to get the price, in this case price calculator. You call accept on the fruit giving the visitor, and the accept method of the fruit class will be called, which calls the visit method passing itself as a parameter, which will calculate the price tailored for the fruit class, and then output, in this case 10, because 5 times 2 is 10. So that's the code, and these are the resources I used, and that's about it. Thank you.